So working with AI coding agents is, it's actually a lot like hiring this really eager but completely naive contractor.
Oh, absolutely. Like they want to build something great, but they have no idea what they're doing.
Right. If you just sort of wave your hands and say, build me a house,
Yeah.
you don't give them a strict budget or like hyper-specific blueprints. They will excitedly build you an incredibly expensive, unlivable mansion.
And you just absolutely cannot maintain it.
Exactly. So to stop that from happening, we're doing a deep dive today into this really fascinating strategy. We're looking at how to build secure features fast and essentially for pennies.
Yeah, we're unpacking this DEV community article. It's by Alexander Tootin called Antigravity, my approach to deliver the most assured value for the least money.
And the author brings a really interesting perspective to this, right?
Yeah.
Because he actively describes himself as a non-professional developer.
I mean, that's the best part. He isn't interested in writing beautiful, esoteric code just for the sake of it. He just needs automation to get functional things done.
Right, it's very pragmatic.
Completely. Because of that, he applies this ruthless efficiency to the whole process. He leans heavily on the Pareto rule. The idea that you spend 20% of the effort to get 80% of the result.
Which is so refreshing in tech right now.
Yeah, his core philosophy is just that overengineering actively hurts your project. So the goal is never to let the AI write this wildly complex code that a human can't decipher. The goal is simple, readable, and highly constrained development.
Which means we really need to talk about managing resources.
Yeah.
And in the AI world, that means managing your token economy.
Oh, tokens, yeah. Every action your AI takes has a computational cost.
Right. And the strategy outlined here for mitigating that is incredibly deliberate.
Yeah.
Basically, you swap out your models based entirely on the difficulty of the task at hand.
Yeah, the heavy lifting, so planning the architecture, mapping out complex business logic, establishing security frameworks, that kind of thing.
And evaluating potential cloud costs, right?
Exactly. All of that is strictly reserved for high-tier, expensive models. But then the strategy shifts, like, aggressively.
How so?
Well, for anything that resembles grunt work, you move to lower-tier models. I mean, if the task is just fixing a syntax error or aligning the code to standard formatting.
Or just spitting out standard boilerplate.
Right, there's absolutely no reason to burn premium tokens on that. You use a lighter, cheaper model to just do the heavy typing.
But wait, hold on. If I'm constantly bouncing my code base between like a GPT-4 level model and some basic syntax checker model, isn't that just shredding my context window?
It sounds like it would be, yeah.
Like that sounds like an absolute version control nightmare. Wouldn't it be fundamentally safer to just use the smartest model for everything so it, retains the full memory of the project and doesn't make stupid out of context mistakes?
It seems counterintuitive, but using the smartest model for everything is actually how you break the system.
Wait, really?
Yeah, because it isn't just about the financial cost of the tokens. It's about the mechanics of context windows themselves. When you feed a large language model way too much text over a really long session, the attention mechanism actually starts to degrade.
Oh, like the needle and haystack problem.
Exactly. The model gets confused by its own massive memory of previous prompts. It loses track of the core instructions, and honestly, it just starts hallucinating.
So you end up wasting premium tokens churning out broken code anyway?
Yep, because the model is just totally overwhelmed by the sheer volume of context.
Wow. Which, that solves a massive problem with RJ retrieval augmented generation pipelines.
Oh, absolutely.
Because a lot of developers spend huge amounts of time and money building complex vector databases just to feed their AI the right context. But this approach kind of bypasses that completely through task decomposition.
Right. The author breaks every single task down into these micro pieces. And crucially, he stores all the architecture plans and instructions directly inside the code repository.
Oh, I love this detail. He just uses a local docs folder right there in the repo.
Exactly. So you don't need this elaborate database. The AI's context is literally just the file structure it's already working in.
That is so smart. Keeping the instructions co-located with the code is brilliant for context management.
Yeah, when the AI is asked to work on a specific micro task, the blueprint is sitting right next to the code file. It doesn't have to go search an external wiki or, fetch data from a disconnected project management API.
So the rules of engagement are self-contained.
Precisely. Meaning you only feed the AI the exact tokens it needs for that specific operation. It keeps the context window incredibly clean.
Okay, but if the AI is prone to just writing code blindly, how do we actually stop that reflex? Because even with a microtask and a clean context window, our eager contractor might decide to just invent a totally convoluted solution just because it can.
Yeah, they love doing that. You constrain it by forcing a really rigid structure on every single task before a single line of code is generated.
Like a mandatory framework.
Exactly. It fundamentally changes how the AI approaches the problem. First, the AI have to articulate the idea. It must explicitly justify why the task matters.
Oh, so it's forcing the AI to prove its worth.
Right. It has to state the business or technical goal clearly, validating that the task is actually useful before we spend any compute power delivering code to review.
Okay, I like that. And once the why is established,
then the AI is forced to generate the plan. This is the technical blueprint, and it serves as a really strict boundary. It locks down the security approach and specifically prohibits the AI from inventing clever, unapproved solutions.
No going rogue.
Exactly. By writing the plan out first, the model creates a deterministic path for itself. It severely limits the chances of hallucination when it actually starts coding.
And once the code is written, the framework demands that the AI leave, essentially a trail of breadcrumbs.
Yeah, the what was done log.
Right. It has to generate a short log of what was actually done, which is just pure future-proofing.
It saves so much time later. The next time an agent is dropped into the project, it just reads that short summary. Instead of burning thousands of tokens, scanning every single file to figure out what happened in the last commit.
That makes so much sense. But there was a fourth part too, right?
Yes, and the final constraint is arguably the most critical: documenting technical debt.
Ah, the debt.
Yeah, if the AI took any shortcuts, what the author calls crutches, to get the code working, it must declare them openly.
Because hidden debt is what ultimately destroys code bases.
Exactly. So if the AI used like a brute force loop instead of a properly optimized query, it has to document that decision immediately.
It's like forcing the AI to write a mandatory apology letter for any messy code it leaves behind.
Basically, yeah. And that behavior is enforced by some incredibly strict system prompts. You don't just ask the AI nicely to be clean, you hard code the boundaries.
Right, the system instructions explicitly state no unapproved crutches.
Yep. If a shortcut is used, a human must approve it, and the AI must flag it as debt.
And the constraints go even further. The system prompt explicitly forbids inventing wheels, right?
Oh, yeah. If a working authentication method or database connection already exists somewhere else in the project, the AI is instructed to reuse that exact code.
It's also commanded to review its own past technical debt before starting a new service, just ensuring it doesn't repeat the same structural mistakes.
Which takes ego completely out of the equation.
Yeah, it really does. The system instructions even dictate that the code must be simple. It restricts the use of overly complex standard classes and outright bans those, extreme genius-level one-liners that nobody can actually read.
The golden rule in the prompt is maintainability first. The AI is told that a mid-level, part-time human developer must be able to easily read and alter the code.
So it completely shifts the AI's persona from this rogue genius architect to basically a highly efficient typist.
That's a perfect way to put it. But having theoretical rules in a prompt is very different from enforcing those rules in production.
Right, theory versus practice.
Exactly. Which brings us to the operational workflow. It acts as a series of strict quality gates. The process begins with a high-tier model defining the code structure and cost limits. But then, the human operator manually reviews that blueprint with a fresh eye before any coding actually begins.
So you approve the architectural blueprints before anyone picks up a hammer.
Precisely. Then the actual coding is handed off to a lower-tier model to implement exactly as planned. And once written, a mid- or high-tier model reviews the work.
And this is where we see a really clever cost-saving optimization regarding linting.
Oh, the formatting. Yeah.
Because you should never pay an LLM to fix missing spaces or correct indentation. The author completely offloads that to free external tools like AutoPep8 and Rough.
Such a huge money saver. You save your context window and your budget for actual logic, while traditional scripts just handle the formatting.
Right. But offloading the formatting is efficient, sure, but the workflow's true defense mechanism happens right before the code is merged, doesn't it?
Yes, this is my favorite part. The author built a custom nano service using the Vertex API, and it serves as the ultimate unforgiving gatekeeper.
Unforgiving is right.
He designed it to automatically review code changes by simulating the combined perspectives of a chief technology officer, a chief information security officer, and a chief financial officer.
Okay, so it's less like a standard code review and more like an automated customs agent at the border of your code base.
Oh, yeah, checking the passport of every single line of code before it gets merged.
But how does it actually simulate those roles? I mean, how does an API act like a CFO?
It all comes down to how the prompt weights are partitioned and what data it's analyzing. The nano service isn't looking at the whole chat history. It only looks at the final diff, the exact lines of code being added or removed.
Oh, I see.
Right, so to act as a CFO, the system prompt directs the AI to specifically scan that diff for financial risks. It looks for unoptimized database queries that might run out of control, or recursive API calls that could accidentally spite a cloud billing account overnight.
And for the CISO persona.
It scans the diff for exposed credentials, insecure endpoints, or improper data handling.
But wait, if the IDE's built-in AI models, the ones you've been using all along, have already reviewed this code multiple times during the building phase, why do we need this separate Vertex API customs agent at the very end?
Yeah, it feels a little redundant, right? Having an AI review code that was just reviewed by another AI.
Exactly.
But the redundancy is actually the whole point because it eliminates a massive blind spot. The IDE models, the ones you're chatting with while you bill again, they suffer from severe context fatigue. After 6, 7, maybe 9 rounds of iterative debugging and chatting, those models lose the forest for the trees. They get so hyper-focused on fixing a specific error that they miss the broader architectural or security implications of the fix.
You get tunnel vision.
Totally. The Vertex API nano service has zero baggage. It hasn't been part of the debugging struggle. It provides a completely fresh, sterile evaluation of the final output.
So it's completely objective.
Exactly. It checks the diff against the core project rules, and if it detects any unapproved technical debt, like that hard-coded database credential we mentioned earlier, it executes a hard stop. It completely blocks the pull request from merging.
It just shuts the door entirely.
Wow.
And that rigorous, almost paranoid level of constraint is clearly what developers are starving for right now.
Oh, no doubt.
If you look at the comment section on this DEV community post, the reaction is incredibly telling. You've got an avalanche of likes, unicorns, exploding head reactions.
Yeah, the community loved it.
But the most significant validation came from Jess Lee.
Right, the co-founder and COO of Forum.
Yes, which is the actual platform DEV community is built on.
Hmm.
Just bookmarked the workflow and actively tagged other tech leaders to review it.
And when C-level executives of major developer platforms are studying your personal deployment pipeline, it signals a major shift in the industry's mindset.
It really does.
We have officially moved past the honeymoon phase of simply marveling that AI can write functional code. The industry is now desperately trying to figure out how to put a harness on it.
Yeah, how to control the beast.
Exactly. Pragmatic, highly controlled, and cost-conscious workflows are becoming the new gold standard because companies are realizing that unconstrained AI will either bankrupt their cloud accounts or create a tangled web of technical debt that humans just can't untangle.
It's the necessary maturation of the technology.
Hmm.
But this entire framework leaves us with some incredibly compelling questions that warrant deeper independent research.
Oh, absolutely.
Because while this works beautifully for a solo developer, the mechanics of scaling it are incredibly complex.
Right.
It's that in-repo documentation method we talked about.
Storing the docs locally, yeah.
Right. Storing your architecture plans and your technical debt logs directly in the local file structure is brilliant for one person.
Mm.
But what happens when you have a team of 20 developers pinging the repository simultaneously?
Yeah, scaling that specific mechanism introduces severe version control challenges. I mean, if multiple human agents and their respective AI assistants are constantly updating the same local documentation files, you are going to generate massive merge conflicts in that docs folder itself.
It would be chaos.
Complete chaos. So the research question becomes, how do you manage the context window strategy when multiple agents are introducing conflicting requirements into the same localized space? Do you need a completely separate pipeline just to merge the AI's memory logs?
And taking that a step further, think about the prompt engineering required for those technical debt logs.
Oh, getting them to admit they messed up.
Exactly. We know that large language models are inherently people pleasers. They're designed to give you the answer you want. So what exact sequence of system prompts is required to force a model to reliably and honestly document its own technical shortcuts without hallucinating a justification?
Yeah, forcing an AI to confess that it wrote bad code requires incredibly rigid adversarial prompt engineering.
And balancing the weights in those adversarial prompts is a massive technical challenge. Because if you make the prompt too aggressive, the AI might refuse to write code entirely. It might just constantly flag its own valid solutions as technical debt.
But if you make it too lenient, it hides the crutches.
Exactly. Calibrating that nano service to perfectly balance the demands of a CTO wanting elegant architecture, a CSO demanding ironclad security, and a CFO requiring strict cost reduction that is an art form that the industry is still actively refining.
Which means the core takeaway from all of this is just a massive reality check. AI coding is not magic. It's a tool.
Just a tool.
And like any piece of heavy machinery, it requires the human operator to completely own the process. You cannot just hand over the keys and assume the machine knows where to drive.
You really can't. By aggressively managing your token economy through model swapping and enforcing those rigid justification frameworks before the code is even written.
And deploying automated customs agents like the Vertex API.
Yes, all of that. You fundamentally change the dynamic. You stop treating the AI as a genius architect, and you start utilizing it as a highly efficient, closely monitored typist.
That is the only sustainable way to ship secure, maintainable code at a high velocity.
It's all about ensuring the machine follows your blueprint to the letter, catching every single deviation before it hits production.
Absolutely.
But before we wrap up today, we want to leave you with one final thought to mull over as you explore these frameworks.
Yeah, consider the trajectory of that Vertex API nanoservice. If a simple, localized AI tool can be trained to effectively simulate a CTO, a CISO, and a CFO,
Right.
if it can relentlessly gatekeep AI-generated code,
Yep.
checking for hidden debt, structural integrity, and cloud costs, how long until enterprise companies start deploying those exact same automated gates to evaluate the code of their human developers?
Oh, wow.
And what happens to the culture of software engineering when the final arbiter of your work, the gatekeeper that decides if your code is good enough to deploy, is an AI that is far stricter and far less forgiving than any human manager ever was?
That is a fascinating and frankly slightly terrifying vision of the future. The AI isn't just writing the code base. It's evolving into the absolute boss of the repository. So keep questioning your tools, keep digging into the architecture behind the automation, and we will catch you on the next deep dive.